So previously on Andy's Boring Job, I was attempting to fix a Mackie d.2 Pro, which had a fader that didn't work properly and some glowing blue knobs that didn't light up. There is actually another fault with this unit, but we'll come to that later. Now, I fixed the fader last time, but I didn't have any LEDs to fix these glowing blue knobs with, so I ordered them and they arrived today. So the way these knobs glow is underneath each pot, there's a little blue surface mount LED, and the pot has a sort of translucent shaft that shines up into the knob, which is also translucent. Now what had happened was, each group of 3 LEDs had one or more LEDs blown in it, and because the LEDs are wired in series, if any one LED blows, the other 2 also won't light up. It's a bit like the old-fashioned Christmas tree lights. Now, I can't be bothered figuring out which LEDs are blown and which ones aren't, so I'm just going to replace all 6 of them. Also, that'll ensure that there isn't any variance in colour or brightness between the LEDs, because obviously the ones I'm about to put on aren't probably from the same manufacturer as the original. So the first thing we need to do is desolder the old LEDs. Now, for 2-terminal surface mount components like resistors, capacitors and diodes, I find the easiest way is to just put a massive blob of solder on one of the pads, heat that up for a couple of seconds, and then just very, very quickly move the iron to the other pad and just flick the whole component off. Because the big blob of solder will still be molten by the time the iron reaches the other pad, and then the whole component will just come straight off. For components like ICs that have a lot more pins, generally I would use a hot air rework tool, which I do have one of, but just for stuff like this, it's just not worth the time, especially as there's a lot of potentially heat-sensitive components surrounding those LEDs, like electrolytic capacitors and plastic connectors and so on. Anyway, once the old LEDs are off, it's time to clean the pads just with a little bit of solder flux and some solder braid, and then put the new LEDs on. The LEDs I ordered were 0603 LEDs. I'll maybe link to the datasheet down below. They're quite small, but yeah, I mean, with a little bit of practice and a steady hand, they're not too hard to solder on. Everybody has their own favourite way of soldering surface mount components, but personally I like to put a little bit of solder on one of the pads, then while keeping that solder molten, lower the component down, then let the solder solidify, and that just kind of keeps the component in place so you can solder the rest of the pads. Once we've got the first 3 done, we can test that we're not making any stupid mistakes, so just connect it up to the power supply, and yeah, that looks good. Time to do the other 3 now. Once we've done that, we just have to solder the pots back down, and yeah, all working fine. Time to put it back together. Or is it? Now, this is actually something that Matt, who owns this mixer, told me about, but I completely forgot. Basically, the VU meter LEDs aren't lighting up properly. It just seems that once you get past a certain volume, the bottom few LEDs in the VU bar graph just stop working. The VU bar graph is a fairly typical design. It uses a chain of LM339 comparators, each of which is set to compare the input volume level to a predefined voltage. If the volume is above a certain point, then the comparator will light up its associated LED. Now, there's a bit more going on with this particular comparator circuit, since the LEDs are wired in series, and there's a few transistors doing something as well. I didn't really have time to reverse engineer it, but the upshot of all this is basically it's the same as what happened with the LEDs under the knobs. One of the LEDs has failed, and that's taken out an entire group of them. Unfortunately, the LEDs in this particular meter are a bit of a non-standard size. I think they were 2mm by 4mm, rather than the typical 2x5 you normally see rectangular LEDs in. And I couldn't find any in my normal component suppliers. I think Mauser had some, but I didn't really want to spend the 20 quid minimum fee just for like a 5p LED. So I decided to try a bit more of a ghetto approach. I decided to cut the top off the broken LED and just attach it to the top of a more standard sized LED that I just had lying around the workshop. Actually, I took the working LED off the main circuit board of a URI 1601 mixer, which I mentioned in the previous video, but I didn't think it was going to come up again in this video. This actually used to be my mixer back in the day, but it just is now in the big pile of circuit boards that has useful components on it that I sometimes steal stuff from. So yeah, now that's soldered on, we just have to very carefully attach the dead carcass of the old LED to it, and yeah, that looks great. All seems to be working fine. Now I really can put it back together. I often find when reassembling equipment that I can't remember where the screws came out of is just organise the screws into identical piles. That way it's often obvious just by counting the number of screws exactly which screws go into which holes, but this particular mixer had a few screws missing anyway, so I'm going to have to find some new ones to replace them with. So yeah, after much fiddling around and swearing, I managed to get it back together. Now here's my favourite part of repairing scratch mixers.